All right. Welcome everybody to the first meeting of the year for the Central Florida Astronomical Society. My name is Wesley Clem. I am the president of the club, and Happy New Year, everyone. And is everyone enjoying those clear skies that aren't really happening so far this year? I just want to go ahead and get into the meeting here. Um, Before we get into the things, if you're not already a member of the club, let's just go over the reasons why you should be. You have access to private events that the club offers, the dark sky viewing locations out at Geneva. We have our star parties. We also have our Loner Scope program and our remote observing program. If you were not familiar with that, we have a sea star located out in the dark skies of Texas at Starfront Observatories, where you can reserve time and use that and get some awesome pictures, even with just a sea star. It's really amazing. We have our online community on groups.io. Be sure to join that if you're not already. We have our quarterly meetings at the Seminole State Planetarium, where, I mean, now you can't come up with a better place to have an in-person meeting for an astro club than a planetarium, right? We have our breakout sessions, usually a planetarium show. It's a great place to have a meeting. It also comes with the membership of the Astronomical League, which comes with the Reflector magazine. And also, don't forget, we are a nonprofit 501(c)(3) organization. We are all volunteers here. None of us get paid. We just do it because we love it. We all love this hobby and want to further it and spread that love to the community. And of course, you also get the discounts on astronomy and sky and telescope magazines. So take advantage of that if you can. Tonight's agenda, we have Melissa Kaelin. She's chasing the Aurora in a solar maximum and beyond. Followed that by club news, upcoming events, and then finally our astrophotography showcase. And we have a bunch tonight, so stay tuned for that. It was clear in November and December, so we've got some good images from then. So yeah, let's go ahead and switch over to Melissa Kaelin. Melissa is the co-founder of the Aurora Summit, founder of the Michigan Aurora Chasers, and the author of the Beyond the 45th Parallel, The Beginner's Guide to Chasing the Aurora in the Mid-latitudes. She served on the ground support team for the SolarMax mission to study the aurora from space in April 2025. She leads guided aurora chasers during strong geomagnetic storms, and she has served as a guide on international tours for the Northern Lights. Welcome, Melissa. Thank you so much for being here tonight. And really looking forward to your presentation.
Thank you. Thank you for having me. Super excited to be here. I was down in Florida a little while ago. Let's see, I guess it was all the way back in 2020 now, to see a launch at Cape Canaveral. So met a lot of local folks who are into some of the same types of hobbies, and I'm a huge fan. Really grateful to all of you for having me. And bear with me, this is my first talk of the year. So I'm gonna dive in. There's a lot to cover, but I'm happy to answer your questions. We'll probably do that at the end, but feel free to interrupt me if that ends up being better. So chasing the aurora at solar maximum and beyond. This is a photo that was taken of me in Michigan, October 2024, while chasing the Northern Lights. And yeah, I'm pretty into it. I've been chasing the aurora for over 13 years. I started when I lived in Minnesota, a little bit farther north, but it took me over a year and a half to catch my first aurora. When I started out, I had no idea what I was doing. And I don't have a science background, actually. I am a writer at heart and love books. And in eighth grade science class, I was not really the best student. I think my teacher used to kind of have pity on me a little bit because I just wasn't really that engaged. But here I am doing science now with a journalism degree, just a bachelor's in journalism. This photo was taken in, let's see, we're in 2026 now. So happy New Year. This photo was taken last year in March of 2025 when I was invited up to the Northwest Territories of Northern Canada to chase the Northern Lights. We caught all sky aurora for 4 nights in a row, all night long. And that's me standing on the ice trucker roads, made popular by the TV series. The temperature at the time was negative 26 degrees Fahrenheit, and it was about 3:30 in the morning, but we had aurora all around us in the sky. That was kind of the highlight of last year for me. So here's a little bit more about me. You've heard a lot already, but I also was invited to write a column for Amateur Astronomy magazine. I've been doing that since 2025. Um, I'm a tour guide for the University of Michigan Alumni Association. Last time I went to Iceland, that was my first trip as an international tour guide. And in about a month, I'm leaving for Finland to stay in the glass cabins or glass igloos. I was a NASA social media ambassador when I went down to Florida for the solar orbiter launch. And yeah, I live in Michigan and have for going on 7 years now. So at night, I chase the aurora, and by day, I actually am super fortunate that the stars have aligned and my hobby and my occupation have collided. By day, I'm a science communicator. I took that degree in journalism and experience and reporting and translated into working for universities and colleges. So I'm now the manager of marketing and communications for the University of Michigan Department of Climate and Space Sciences and Engineering. So we do a lot of partnerships with NASA and NOAA. We work a lot on space weather and space weather prediction. In fact, they have a brand new app that came out of our department from some faculty who are working on it called Aurora Tonight. Um, and so you could all check that out if you wanted. And I also adopted a puppy if I wasn't busy enough. I named him after the sun, which is pictured on his back. If you can see that photo in the top corner there, it kind of looks like the solar eclipse. And so this is Elio, named from Helios. So I actually need to update this slide. I've chased the aurora and caught it now in 4 different states in the US, including Alaska, where I traveled for about a week and caught aurora 7 out of 8 nights, including the arriving into the airport in Fairbanks and departing from Fairbanks. So it's actually really cool to see it from the plane if you get a chance. And then I've also now seen aurora in Iceland, Canada, and Norway, where I went aurora chasing at sea last year on a 2 week cruise aboard a Hurtigruten ship. So if anyone has questions on that, I'm happy to answer more. Um, and yeah, there's a lot to go through. So some of these slides I'll really cruise through. Um, but we here, if we're trying to catch the Northern Lights, are trying to do something that some people believe is impossible or nearly impossible. It wasn't until I think the last couple years, especially May 2024 during the Gannon storm, when people realized that you could see the Northern Lights all over the United States. Normally, we think of the Northern Lights as being something that happens all the way near the North Pole or in places like Alaska and Finland. Those are the northern latitudes. We live in what I would call the mid-latitudes. And, Florida gets us a little bit closer to the equator than where I am in Michigan. But my whole goal is to help people catch the aurora in the mid-latitudes where it's even more rare. So, the thing that helps most, and I've learned this myself up close and personal last August, is dark skies. And of course, as astrophotographers and astronomy fans, you all know that. But the darker your skies, the better your chances of seeing an aurora. I've become a huge fan of international dark sky parks and even a higher level of international dark sky sanctuaries. We actually have a sanctuary right here in Michigan, and hopefully you have dark sky parks and dark sky sanctuaries near you too. But these guys can really help us see more. This darkness can help us see more in the skies. So this photo was taken by Justin Miller from the Michigan Aurora Chasers. He's now moved out to Maine. But he took this in Michigan. On one side, you can see that pink glow of the aurora rising low on the horizon. On the other side, what you're seeing is light pollution, and you probably all know that, but it has a completely different color. And then this photo was taken of the Milky Way in the middle. So in these dark sky areas, you get just a glorious view of the Milky Way. If you haven't seen the Milky Way in one of these places, I highly recommend it. And I think he even caught a little bit of what we call air glow, which is, if you haven't heard of it, sort of it can be many colors actually, but it's often like a green or blue glow in the sky that is usually only visible on camera. But in this dark sky sanctuary in Michigan, I saw it with my own eyes, just barely. So, when are the peak conditions to catch aurora or the best times? You can actually sort of use the science and you can use a lot of the trends to help you get better at catching the aurora. Solar maximum is, for those of you that don't know, it's the peak of an 11-year solar cycle of the sun. So the sun will cycle through every 11 years, where it reverses its poles. And actually, it cycles through once for 11 years and a second time for a 22-year cycle. And over the course of those 11 years, each time we gradually increase in how often and how bright we are seeing the aurora, and then we gradually decrease after solar maximum. So there's a scientific panel that has been judging when solar maximum may have hit. They determine that by the number of sunspots on the surface of the sun. And scientists believe that we hit solar max in the fall of 2024. Does that mean we can't see aurora now? Well, no, because that peak is then going to lead to a gradual decline. And actually, working with experts in the field, they will tell me that the year or two after solar maximum sometimes has some of the most explosive aurora. So is it not going to be often, but if you're watching for it, you can really catch some good stuff. There is a peak season, and this is true all the way around the world. It has to do with the tilt of the Earth on its axis. The peak season for seeing aurora is about from September to April. So usually around the time of the fall equinox is when we start seeing the season ramp up, and then by the spring equinox, we're seeing the season turn the other way. Now, why is that the peak season? It has to do a lot with Earth's alignment with the sun, which is a major scientific factor. But of course, most places in the world also have longer nights and darker skies during that time of year. And of course, in some parts of the world, you can't get aurora at all in the summer. In fact, the places that are most popular. So it's nice that here in the US, we can see it year round. The peak times to catch aurora are in a generalization, these are all generalizations. So aurora can happen anytime. But in general, 2 hours before and after local magnetic midnight are going to give you a stronger chance of catching the northern lights because the aurora rotates around the poles of our Earth, and that auroral ring is going to be more centered above us at our local midnight. So 2 hours before and after local midnight is always a good time to watch. Here's a photo taken by one of the Michigan Aurora Chasers. If you haven't heard of us, the Michigan Aurora Chasers started as a Facebook group. We now have a website and free Aurora alerts that can help you know when the Aurora are active in the US. Not Alaska, but the lower 48 states. Well, Alaska too, probably. And this photo was taken by one of our admins, Christina Cantu Sharp. What I love about this photo is she's taking a photo of the Mackinac Bridge over the Great Lakes, which is an extremely tall bridge. In fact, it rivals the Golden Gate Bridge in San Francisco, and I think it's actually taller. So the Mackinac Bridge is a really tall bridge, and there you see the pillars of the aurora so much taller. She titled this photo Northern Dawn. And what's interesting about this is it was taken at about 6 o'clock in the morning. So not in the middle of the night. The sun was about to rise. And all the colors in the photo were 100% naked eye visible, she said, from that night. I wasn't awake. I missed this one. But what I love about Northern Dawn is that it sort of hollers back to some of the mythology about the Northern Lights. In Greek and Roman mythology, Aurora was known as the goddess of the dawn. And As legend had it, her job was to escort the chariot of the sun god Apollo into the sky each morning. So, if you think about when the sun comes up and the sun rises and Apollo moving into the sky, Aurora would come out right before that. And so, when I first started chasing, I actually missed a ton of Aurora until I started staying up closer to dawn. And that 3 o'clock in the morning, 4 o'clock in the morning time frame can really be full of surprises. I think the big one that cued me on to doing things differently happened at 5 a.m. This is a photo taken by admin Nate Stovall. He since moves from the Michigan Aurora Chasers to be a tour guide in Alaska. So we're all a bit obsessed up here. This is a photo of what we call the corona, and this was taken straight overhead. So in May of 2024, a lot of people caught photos of the corona looking right above them. It Corona is something that happens when all the veils and curls and wisp of the aurora converge in the center of the sky and the apex of the night sky. And it can be really colorful. It's often really dynamic and really moves and creates a lot of shapes. And that's where we hear stories about dragons and phoenix and angels or bears, all these shapes that you can see in the sky. But one thing to note is that when you're chasing in the mid-latitudes, this also may be a really colorful photo that is not colorful to your eye and then pops like this on camera. And I'll talk about that a little bit more later. But I've become really well known for helping people catch the Northern Lights. I wrote a book that has helped lots of people see the Northern Lights for the first time. It has great advice that you can use no matter where you are in your Aurora chasing journey. And our group has helped, between the group and the book and our guided chases, we have helped thousands of people catch the Northern Lights for the first time. So, one of the things I'm really known for is these guides that we've either created in the group and as a team or that I've created myself on my own website. Finding a good viewing location can sometimes be the hardest part because you not only want dark skies, you also typically want it to be looking north. In any kind of typical aurora, and I shouldn't even describe it as typical. Aurora is never the same. No two nights are the same. But usually, when you're viewing aurora, you want to be able to see the north, and not only the north, but low on the northern horizon. Yes, it can come above you. It can come to the west and to the east, and even to your south, depending on where you are in the country. But it always starts its phases in the north, and then it spans from there. So I have a guide on my website to help you find a viewing location wherever you're at. I should have taken a screenshot of Florida for this one, but hopefully you've heard of dark sky maps or light pollution maps. Those can really help you pinpoint where dark skies are in your region. Just give it a search on the internet, or we have them linked to our website at michiganaurochasers.com, and then you'll pull up interactive maps like this. What I love about them is that you'll see these red splotches and purple splotches where the cities are, and there's so much light pollution, it's going to make it much more difficult to see the northern lights. And then you can zoom in and you can look around different neighborhoods and communities, maybe parks or lake shores, and find where the darker spots are without obstructions to your north in those blue and purple areas and get to dark skies. And I have a video on my YouTube where you can really sort of pinpoint this and find a dark spot anywhere. I went on a search for one in North Dakota, of all places. I've never been to North Dakota, and I found a great spot. But you can use it to find spots in your neighborhood. It might only be 5 or 10 miles from home, so a lot of people don't realize that. Here are just kind of a look at some of the guides I've shared. We have in our Facebook group, the Michigan Aurora Chasers, over 133,000 members. In fact, next week will be our fifth anniversary. We've only been around for 5 years, but wow, have we grown. And anytime I see some of our members struggling with an issue like, well, where do I go? Okay, I've gone to all the lake shores. What other kind of viewing spots can I find? Or what do I need to know about night sky etiquette? Or why why did everyone catch the aurora last night except for me? That's what led to this article I screenshotted here in the bottom corner. Ask how to see the aurora, not where. Because in some ways, on some level, during the really strong displays, it doesn't matter where you are. You just have to know what to look for, and you kind of have to learn the game. So these are some of the articles and guides that I've got available on my website. I've written an entire advice blog with Aurora chasing advice for chasing in the mid-latitudes in the US, and a YouTube channel on chasing the Aurora in your backyard. And our resource list has everything from webcams that you can check in near you, or at least in northern parts where they are watching for aurora, to, sort of glossaries and definitions, to field guides and videos that will help you learn the game. So this is us. This is the Michigan Aurora Chasers. I've been talking a lot about what we have to offer already, but the good news is you don't have to be a member, you don't have to join, you don't have to pay us anything. We built a website. We wanted to provide a public resource, and so that's out there for anyone, and you're welcome to share it with all your friends and family. MichiganAuroraChasers.com. It's got a lot of really great stuff on there. And we're about to celebrate 5 years with a lot of photography contests and exhibits and different things like that. We also created a free Aurora Alerts channel, and we're using an app called Telegram if you don't have it. If you don't have it, the downside is it does get a little spammy. You can get some spam on there, but if you lock down your settings real well, you can follow us at Michigan Aurora Alerts. And what you're going to get is a one-way channel that tells you Aurora spotted, time, date, place. And so you'll know exactly where Aurora are being seen. We not only do this for the state of Michigan, which I know is not that relevant to Florida, but hey, if Aurora is coming overhead in all of Michigan, it might be pushing farther south to Florida. It is possible to see it in Florida. Um, and some of you probably have, especially with solar maximum having recently occurred. But those alerts can tell you when it's getting really good. And there's also a photo with each one of them, so you can see how bright and how strong and how tall those aurora pillars are getting, which is really helpful. And the other thing I was going to say is we also built the Aurora Relay channel. Let me know if you want to be a spotter. We're gathering spotters from across this region and this time zone in many states to tell us when the aurora is out. So the Michigan Aurora Chasers has become kind of a beloved, sort of casually, loosely put together club, because we're leading guided chases. And, I started the group and then I brought on one admin right away. His name was Nate Stovall, whose photo you already saw. And he said, "Hey, Melissa, I've got an idea. Like we've been helping people see the Northern Lights with our advice, but I think we should actually get people out there." He said, "How about this? How about we post an announcement to everyone in the public, invite them to meet us in the dark, and guide them right to the Northern Lights?" And I said, "Nate, you want me to invite how many strangers and meet them in the dark?" And like, wow, you're crazy. Like this will never work. But that's what we do. We started doing guided chases. They became really popular, especially our live chase, which we announced at the last minute when we are almost like 99% sure there's a chance. And we guide people to the Northern Lights, and it has been the best thing. We also participate as speakers in a lot of festivals and programs and things like that. So you're probably all wondering how to photograph the Northern Lights because I know that a lot of people love that. And we've got settings that can help you on any device, but I'm going to give you a little bit of advice first. There's some things to consider if you're new to this. And as astrophotographers or astronomers, you might know some of this, but it's really great to scout out a location during the daylight or when you still have light and you can see where you're going. We've thought of all kinds of reasons that this is really wise. You can find a spot where there's not a swamp that you could sink into nearby. You can learn the lay of the land and not accidentally step into the Gulf of Mexico. But other things like finding animal nests in weird spots that you never wanted to disturb. Some of that stuff is really hard to see in the dark. And then we've even had situations where, say, one day we got so much rain all of a sudden that this really beautiful spot that has perfect potential for photos just got flooded all the way through. And you can't even stand there without water boots, which fine, bring your water boots. But if it feels unsafe, checking out that spot during the light before you're out there in the dark is really going to set you up for success. The other thing I love about scouting, and you probably know this, is you can go to a spot when you can see and you can check, okay, maybe there's a tree over there or a sculpture that you didn't realize was hanging out in the corner, or, a classic road sign that would be perfectly aligned with the northern view. And so when you check out and scout out your location during the daytime or right at sunset or whatever it is, you can set up that perfect composition so that when darkness hits, you've already got to your spot, you're all set up, you're ready to go. You don't have to fool around and mess with your camera or your tripod. So it can set you up for success with your what's the word I'm trying to think of, your composures too. So yeah. Obviously, you guys know avoid light pollution if you can, although it's interesting. There are some studies that and some experiences from that some of us have had that actually show that if you get a certain amount of light coming into your eyes during an aurora display, it can actually activate your night vision a little bit better. We don't see as well in the dark as animals do. We're not nocturnal creatures. We have to rely on the rods and cones in our eyes and the way that those work together. And so, with one collecting color and the other collecting light, it becomes a really steady balance. Typically, the darker your skies, the more successful you'll be and the more color you'll see. And that's almost always true. But there are some rare occasions where a little bit of moonlight or a little bit of light pollution just activates your eyes enough that they're working together. Um, Obviously, we want clear skies, right? And the one thing that we have learned, we have a gal in the Michigan Aurora Chasers, Mary Beck Kozinski, who is known as the Extreme Aurora Chaser. She has gone out on a really high wave lake in the Great Lakes in the middle of the night on a boat and caught Aurora over a little tiny waterfall on the rocks, on the rock cliffs. So, beautiful photo. I totally recommend checking her out. But she actually had an invitation to bring out a reporter from the National Weather Channel. So he came out to follow her to see how she chases and catches northern lights in all these different places. And he came during the worst week. It was the cloudiest, it was the quietest in terms of activity. It was so tough for them to find the aurora. But often you can get it on your camera, even if you can't see it with your eye, because a camera will pick up all light and color in the sky. And you can add on that 30-second exposure where you're stacking seconds and seconds and seconds of color. That's how we get those neon photographs. Um, and so they did catch it on camera. Now, the reporter from the National Weather Channel said, okay, here's the thing about cloud cover and cloud cover forecast. They're always wrong. He pointed out, note that like as humans and in America, we put a lot of resources and investment into understanding when a hurricane will strike and where, or when a tornado will strike and where, or when it snows up here. I'm getting 12 inches of snow today. When it snows, they want to be ready with the snow plows and everything in the north to push that off the roads or to salt the roads before the snow falls. So we've invested all this science and forecasting into understanding these really extreme, or severe weather events. But no one actually cares if it's just going to be cloudy. So it's an area that we haven't had as much invested in the research of, and the models and the information, the data collection that we have for predicting cloud cover really just isn't that strong. It's not enough information. So you're looking at that cloud cover forecast and deciding what to do tonight and thinking you won't have any holes or any chance. Think again. Could be wrong. The reporter basically told us ignore it, ignore cloud cover forecasts. And so what we recommend is instead trying to use real live satellite radar to see where the clouds are and how they're moving and try to maybe anticipate those patterns. But if it's not real time, then maybe like don't plan around it. Um, there's other things to think of like sunset. You know, you can see the aurora right after the sun has set, but you'll never see it when the sun is up. It's just too bright, obviously. Astronomical twilight is going to be the best time to start looking for the aurora or to keep looking for the aurora because that's when we're getting into the twilight that's dark enough that we can see more of the glow. And a new moon is really going to work in your favor unless you're going all the way to the northern or southern parts of the world. Moon doesn't matter. You can see amazing aurora and all of its colors with your own eyes under a full moon in those parts of the world. But in the mid-latitudes, not usually so much. The reliability of the forecast. Are aurora forecasts reliable? Well, the study of forecasting aurora and the space weather that creates it has only been around for several decades. So it's actually fairly new. I like to tell people it's an emerging science, and we're still learning more about it every single day. So the 3-day forecast is really the only forecast that you can start to rely on a little bit. And even that is not going to be reliable. It's going to change anytime we get new information. And in some ways, it's almost kind of an educated guess at what could happen based on what we know and based on the models that we have available. The aurora, though, does come in patterns. So once you start to realize that every aurora is going to have like a quiet onset where it's low on the northern horizon, and then an expansion phase where it really blows up high in the sky and reaches farther south. And then after that, it goes into a recovery phase. And the recovery phase is where you start to see the colors dim, the moving stop, maybe just a faint glow. Those three phases come in patterns. And so when you recognize onset, expansion, and recovery, you can watch for the aurora to go through those three phases over and over again. Maybe a friend called you and said, "Hey, everyone, the aurora is visible in Florida. Get outside right now." And you missed it. You like waited 5 minutes and then it was gone. So don't worry though, because aurora does tend to kind of roll in patterns like waves. I think of waves on the ocean. And if there has been an aurora that strong to reach that far south, chances are after it goes into recovery, it could happen again and come back even brighter and even stronger on that same night. Now, generally not 2 nights in a row, although it does happen in the north. But from sunset to sunrise, I would keep watching. So, and sometimes even into the beginning of the next night, but not usually for 2 full nights in a row. So recognize those patterns. And then keep in mind your safety, your sleep, and your sanity. And as astronomers and astrophotographers, you all know this. But we want everyone to be safe. It's not worth losing your life over aurora. You sometimes have to pack a lot of safety gear, especially chasing in the cold and chasing in the north. Bring first aid materials. The national parks recommend the 10 list, the 10 things that everyone should have in their car. So do those things. Think about your sleep. If you're driving really far, do you have a place to rest? Is a coffee enough to keep you up? And your sanity. We have so many people who say, okay, I want to catch the Northern Lights. This is the night I'm doing it. I'm just going to go when you tell me to. I got to drive an hour and a half. I'm going to make it happen. And then they go for it they're maybe just off by a little bit or a stroke of bad luck or a new cloud rolls in, whatever it is, and they miss it. And it can be so disappointing. If you've ever tried to see it and missed it, it can really be tough. And so my number one tip for Aurora chasers in the lower US is plan at least one other exciting thing you can do on the way so that even if you go all the way out there and come home empty-handed with Aurora, you had something else that really brought you a lot of joy and kept you coming back. And that makes the next chase exciting again instead of feeling like a failure. So what does it take to photograph it? You're going to use your exposure triangle. You really have to balance your aperture, shutter speed, and ISO, obviously, but this is going to adjust as you go. Here are the things you need. You absolutely need a tripod, even if you're photographing with a phone. Phones are getting really good, especially phones made in the last 2 or 3 years. Anything from the iPhone 13 up is going to be amazing. And iPhone 14 made a huge jump in low light photography. And then, of course, some of the Androids and Galaxy have come a really far way too. But that tripod is going to help you focus on the stars and get the stars in focus, and then the aurora is going to move around it. So without that tripod, it's almost really hard, unless you're taking a really quick photograph, to capture a good aurora photo. Um, a lot of people like to use a remote too, so they don't bump that. Even if they're using a phone, or if you're using your camera. If you don't bump your camera while it's doing the work, then you're going to have a clear shot, obviously. And extra batteries. We up here in the north in the cold know that once we're out there in something like 40 degrees, 30 degrees, sometimes it drops down to 10 degrees or below zero, those batteries are going to run out of juice a lot faster. And extra memory cards would be another one for you too. But you're going to want the widest lens you can find because ideally, if you're catching a good aurora show, it's not going to be in one spot. And the more you zoom in, the more you're going to miss the variety and the colors and the detail and some of the structures. So you're never really zooming in. Instead, you want a wide angle camera lens that's going to help you catch as much of the sky as possible. And then the right settings. Have a little bit more about that coming up, and you can jot down these settings, or a lot of my notes are online, or these guides are available on the Michigan Aurora Chasers website. But I will say Aurora is really interesting. Once you see a lot of shows, you'll notice that every display is different. The colors, the timing, the patterns, and the shapes, and also how fast it moves. So some aurora will just glow and it will barely move at all. Some aurora, will be kind of really subtle, low on the horizon, and it'll sort of wave really slowly a little bit, or it'll shoot up pillars. And the pillars are really interesting because that tends to be really dynamic movement. Some of you have probably seen videos or time lapses, but I'll tell you that popular movies don't do it justice. So make sure you're watching a realistic one. Um, and then sometimes the aurora during these really strong storms gets so animated that it starts darting across the sky and doing waves and shapes and all kinds of things, and you're looking in every direction. So what settings are you going to use? Well, a 30-second exposure can get you a really great shot with all that color, but you're gonna miss the movement and some of the structures is all gonna blend together. If you've got a fast moving show, you might come down to 2 seconds, 1 second, maybe a fraction of a second just to capture what you saw in a pillar or something like that. So it really varies. And then your ISO, how much light you let into the camera, is going to adjust too, depending on how bright the aurora are. And I've seen many, many shows for over 13 years now in many parts of the country and the world. And I'll tell you, some of these aurora are really, really subtle. And a lot of people actually mistake them for clouds because they can look sort of silver in the sky. I always kind of look for transparency. If you're seeing something on the horizon and it's transparent, you can see the stars right through it. Maybe it looks silver to the eye. But if it's transparent, maybe take a photo. We call it a test shot. And we'll take our camera, point it north, low on the horizon, take a photo no matter what we're seeing, and then we'll look at it back and probably a long exposure, like 10 seconds or 30 seconds. And with Aurora, even when it's silver on the horizon, the colors will pop on camera no matter what. It seems like even with those really short exposures, the camera just captures that color. It's like as humans, we're all these daytime animals that don't know how to see color at night. And so it's pretty amazing. But you probably noticed that in your astrophotography. So here's some beginning settings for you. Again, you're going to adjust as you go. It's going to depend. Are you watching one of those really pastel displays that is really, really faint? Or what about the show? I wonder if anyone here saw the show on Veterans Day of last year, November 11th, 2025. Had the strongest, one of the strongest factors ever recorded in Aurora chasing history. And we My state was completely clouded over, completely. There was not a spot of clearness in the sky. But everyone who saw it in states around me said it was the brightest thing they've ever seen. The reds and the purples and the pinks and the greens were just bursting. And so then you might actually have to tone your camera settings down to compensate. So we have a guide on our website now called the Camera Note Card, and you can download this. You can share the QR code. You can even screenshot it or save that image to your phone. And this is just a beginner's settings kind of tip sheet that you can have with you on your mobile device. And I've been talking about this a lot already, actually. You know, people will ask me, especially if they've never seen it, can you see the colors of the Northern Lights with your eyes without any help? Well, and it's like I answer a lot of questions in aurora chasing. The answer is it depends. You can actually have three people standing beside each other in the middle of the night watching an aurora display at the same time in the same place, and and just yeah, same exact display. Um, each person could have a wildly different experience. Why is that? Well, what we can see and how much color we can see and how much we can even discern the structure and the movement depends really heavily on our night vision. I apologize if this feels like, beginner information or review for you, but what we've discovered is that there are a lot of differences that will make the experience different for everyone. So each of us has our own unique individual eyesight. And some people only ever see the aurora in black and white. I know a chaser who swears that every single aurora they've ever seen has been only black and white, no matter how bright, no matter how strong the show. Um, think about it. Like some of us may have a degree of color blindness, or we are colorblind, or maybe we could be colorblind and we're never diagnosed. So in that case, you could see different colors. Someone could be telling you saw a lot of reds and greens, and you could be thinking, no, I saw a lot of pinks and purples, or whatever the case may be. Another situation is that young people, kids, actually, because their eyes are so young and so healthy, typically, can see the color a lot better than older people can. So your kids might be seeing way more color in the sky than you. Like keep that in mind if you take them out at night and you're feeling like, well, this is not impressive. There have also been studies done that gender can make a difference. I can only think of one study, so the jury's still out. But there was one study that said that women often see more color in the aurora than men. And then any type of corrective eye care that you've had, corrective lenses, if you have an astigmatism or cataracts, or if you've had laser eye surgery, that is likely going to change how you perceive color and light at night. And so yes, you could go after the strongest aurora shows and increase your chances of seeing the really bright, colorful ones, especially in the darkest skies and farther north if you can get farther north, although that doesn't always matter. Yes, you can really improve your chances because the color will be bright in some displays depending on the location, how strong the aurora is, and what those factors are in the space weather, um, and how dark your skies are. But at the same time, it may be up to your own individual eyesight what you're actually able to see. So how do we predict this thing and see it in the first place? Well, so the cool thing about aurora, of course, is that it comes to us from our sun. All of this aurora activity starts on the surface of the sun in the sun's corona. We often will get activity like a solar flare, and then that solar flare will eject in some cases, not always. So don't trust the headlines about solar flares. We need a solar flare, and then we need that solar flare to eject a coronal mass ejection, then that becomes the solar wind or the space weather that is moving toward the Earth. So, off the surface of the sun, we actually have a lot of different types of activity that can send these bursts of solar matter or solar plasma into space toward the Earth. And then, when that hits our atmosphere and is able to penetrate our magnetic shield, that dark purple line you see there, and penetrate Earth's magnetic field, which are the light purple lines you see in the graphic, Then, if all the conditions align, the solar matter will come streaming into Earth's atmosphere and actually collides with molecules of air like nitrogen, oxygen, helium, and that collision emits color and light. So, oh, going back to this because this is really probably some of the stuff that you guys really want to know. So we're looking for solar flares and big ones, but they don't always have to be big. It doesn't matter how big the solar flare is. They go all the way up to X class. It matters how strong the CME is and how dense the CME is. That's an abbreviation, coronal mass ejection. So we want that ejection. We can also see filaments erupt and create CMEs. During solar minimum, we're going to see more coronal holes. Coronal holes on the sun can release a high-speed solar wind. And so again, it's not literally wind and it's not literally light. It is the matter from the sun and the plasma from the sun that creates the solar wind. And then so that blows out of those coronal holes a lot during solar minimum and can create really strong aurora. We can get glancing blows that can be really powerful, even it usually has to be directed at the earth. But even when it's not, some of those glancing blows can be really powerful. And the reason that in the peak season of aurora chasing, you can go to places like Alaska and Norway and see the aurora almost any night is because there's also an ever-present solar wind that is sort of drifting by Earth all the time. Is it getting into Earth's atmosphere? Not necessarily, or not much. But in the North Pole and the South Pole, which is where the aurora comes in through the auroral rings, it doesn't take much to light up the aurora. And so just little gust of ever-present solar wind can create really beautiful aurora all the time, as long as they have dark skies. We can't see aurora in the daylight. The sun is too bright. So the biggest factor that I look for to cooperate with us is the BZ. We're getting this solar wind burst of it coming from the sun headed toward the earth, and it has all these different factors that create its makeup. And the most important one is the BZ, which is actually the orientation of a magnetic field that is embedded in that burst of solar wind. So every bit of solar wind has its own magnetic field coming out of the sun, and those are all different. They have different variations and different, like identities, more or less. Um, the Earth's magnetic field, for aurora chasing purposes, is always oriented northward. So I do this thing with my thumbs. I don't know if you can see it. So if Earth is oriented northward and we've got a solar wind burst that's coming at us and it's oriented northward, we're talking about the polar orientation. They hit north and north, when you think about magnetic properties, are going to repel that. What we need a southward BZ coming toward our north Earth features, and that is actually going to connect and attract. So we need that magnetism to work in our favor with a negative BZ. Now, if the BZ is north and then south and then north and southward, northward, southward, that is actually creating a lot of instability that with every dip creates a new opportunity to form that attraction and to let that energy flow through into Earth's magnetic field. The more energy flowing in, the more potential we have for all those energized particles to collide with molecules of air and emit oxygen and light. And that's how we get the colors. Depending on what air molecules are existing at what altitudes is how we get some of those color properties. So at high altitudes, oxygen emits a red, which is why often at lower latitudes, we're seeing a lot of red or crimson or pink on the horizon or magenta. Um, Oxygen at low altitudes emits a green glow. And so that's why when you think of the Northern Lights, you might think of green, especially in places like Alaska and Finland, Norway, and Alaska. But then we can get some of these other molecules that produce lots of different colors, and we have seen almost every color of the rainbow. So hydrogen and helium will emit a purple or a pink, and nitrogen is a really rare one to catch that emits a blue glow. All right. We're trying to predict the northern lights. We know a little bit more about the solar wind coming at us and what to watch for. There are many methods to get you started, though. You can go all the way from using the first app you find on your phone, webcams. Turns out most of the best Aurora chasers I know got started using webcams. That is the only way we know for sure Aurora's here, people are seeing it, or at least the camera is, and there's a clearing in the sky to make it possible. The K index is used a lot, so we can go through that. But you can get all the way down into looking at NASA's WSA-NLO model, the CME scoreboard, which ranks every single CME that forecasters, professional scientists are watching, magnetometers, and even analyzing CMEs and studying flux ropes. And so in my department at the University of Michigan, we had people doing their entire PhD on like one topic that goes even deeper than all of this. So you can totally get a degree in this. But the best tools if you're just getting started, like I said, webcams, Telegram alerts. Not only the ones that we offer for free, but the Glendale app is currently probably the most recommended app. It's not in the App Store. Don't look in the App Store. You have to search the internet for Glendale app from Aurora Alerts UK, then follow the instructions to put it on your phone. It's a web-based app. But what they also have is they have a companion channel on Telegram, and it's all automated. They've got this really interesting formula designed by Andy Stables. He's doing using a lot of machine learning and things like that to understand this and to try to detect with new measures how we get not aurora storms or geomagnetic storms, which is what they're called, that creates the aurora, but substorms. Substorms are the really powerful ones that happen within a storm that push farther south and have pillars and shapes and colors and all the good stuff that we want to catch on camera. So he has developed a formula that automatically detects incoming substorms, that onset, and you can get that dinged right to your phone in real time with those alerts from the Glendale, or I'm sorry, from the Telegram app subscribing to the Glendale channel. And then the Glendale app is also really good. Spaceweatherlive.com, the longest standing, most respected place to get started with aurora chasing. And I've got a video on my YouTube that shows you how you can actually sign up for warnings and watches, just like you might get a tornado warning or watch or a hurricane warning and watch from NOAA about incoming strong geomagnetic storms, which create aurora. So we're talking about G storms, the force behind aurora happens on a scale. A lot of people talk about the KP, the K index. That's really simple scale, 0 to 9. 0 is the weakest, 9 is the strongest. And KP9 is what happened in May of 2024 during the Gannon storm, when every single state in Aurora, or every single state in the US got Aurora, and it was even seen near the equator and in many countries. I have a friend who was Aurora chasing that weekend, Vincent Lavina, the Aurora guy, who actually caught it on vacation in the Himalaya Mountains in May 2024. Can you imagine? So KP9, that's a G5 storm that maxes out the scale. But the KP index, anything 0 to 4 at the bottom here, is really kind of standard normal activity. That might be good for Canada. It's good for the most northern parts of Michigan. It's not good for me. It's too weak. It's when we get to those storm levels, and at KP5 we start to see storm levels. So KP5 is the same as a G1 storm, KP6 is the same as a G2 storm, etc. And it goes all the way up to maxing out at G5. Again, May was a G5 storm. When we get to those storm levels, that's really when we start to see substorms more, and that's really when we start to see aurora pushing farther and farther south. You can even map it out with those aurora viewing lines, but I'll tell you, a lot of those are estimates. Even the ones that I create, I feel really weird about because aurora is not the same everywhere. It is regional. And so it's going to be different, um, depending on what region you're in. So what is a G storm? Well, it's more than aurora. In fact, when we root for a really strong aurora, we're actually kind of like rooting for worst case scenario, societal collapse. Because what's going to happen is in a G1 storm, these geomagnetic pulses are going to cause weak fluctuations in the power grid. They have impacts on satellites. Migratory birds and different animals can actually sense them. At a G2 storm or a moderate storm, we start to see some transformer damage sometimes. Um, we actually have to take corrective actions to monitor our spacecraft in space, make sure they stay oriented to their course. And it can affect predictions in space exploration as well. And you can see at the bottom here, it tells you how far south Aurora may be seen. But when you use a camera, it can be seen even farther than what they're saying here in this scale from spaceweather.gov. So by a G3 storm, power system voltage corrections might be required. Ham radio operators are going to start experiencing a lot of problems. Satellites can shake. In any of these storms, astronauts who are not inside a space station would be in serious danger. And then G4 storms severe. You can have widespread voltage control problems on the power grid, again with radio problems and communication problems and satellite navigation. Any navigation, even on your phone that is satellite based, could malfunction. So all of a sudden, you're not getting the right coordinates for where you are on the map. And then at the extreme level, we have seen blackouts of the power grid in places like Ontario, Sweden, places like that. So worst case scenario, if you haven't heard of it and you want to learn more historically about what Aurora is capable of, look up the Carrington event. This happened just as electricity was being broadly brought into people's homes. It was way back in the 1800s. And the Carrington event was so strong, it would have wiped out all that electricity. What happened, though, is it caused surges so powerful that the telegram offices and the telegraph offices caught on fire. And there were a lot of major issues. So if we had a Carrington event today, that would be catastrophic because of how connected we are online, digitally, and that sort of thing. I'm running a little long here, so I don't know how many of these I'll go through in depth. But this is the NASA model. What you can see is the sun in the center there, that circle, shooting off this solar wind or space weather headed toward Earth, the little green dot. And when we end up in the really bright colors of mapping out, that solar wind, that's when we can get hit directly with an impact. A lot of things have to align to make it possible to get that G storm, though, and to see aurora because Earth's magnetic field is sort of naturally designed to protect us. It keeps most of this out, unfortunately, for aurora chasers. Um, for solar winds, you're going to want a really high solar wind speed. It needs to be moving fast. You want a really dense solar wind, full of particles and charged particles, at least 10 per cubic centimeter or more. You're going to want a high BT. The BT measures the total strength of the magnetic field in that solar wind. And then the BZ you'll want it to be a negative number. It can be negative or positive. And BZ okay, so BT has the potential to send BZ to that number in either direction. So we've got a total power of 10 nanoteslas. BZ can either be oriented southward, negative 10 nanoteslas, or oriented northward, positive 10 nanoteslas, or anywhere in between. So you've got your total power, 10 or more is what we're looking for, especially for the strong shows, maybe even stronger in Florida. And BZ, negative 10 or lower is what we're looking for, or that instability of it jumping all over the map. But it can go you know, as far in either direction as BT. We watch for this stuff, its location on the sun. What type of solar activity is it? What class is it? Is it, a C class, which is hardly anything? An M class is good, that's stronger. And X class is the really interesting big stuff. Is it directed toward the Earth? And again, does it have that polar orientation? You can check out these maps on NOAA's website that sort of graph it out for you. And the interesting one to look at here, just for the sake of time, is the top one where you can see BT, that total power in white. The line is actually all the way at the top here at 10. And BZ in red is mapped out on the same part of the graph, but it's hovering right around zero and bouncing back and forth. As long as that BZ dips below zero at some point within the last, let's say, 6 to 8 hours, you still have a chance. And then you can watch that red line and see if it will dip as far south as the white line has jumped. I love the ovation model. This is a really simple view that you can get from a website. We have it linked to our resources. Looking at the Earth from the top down, you're watching nighttime move around the globe. And as nighttime moves, the auroral oval follows it. It rotates around the North Pole. And so at that local magnetic midnight, the oval reaches deeper down into your region than it does during other parts of the day. But once you see 90 to 100 gigawatts in this top hemispheric power index, or HPI, in the top corner, once you see 90 to 100 gigawatts of hemispheric power on this map, that means you've got a really powerful show coming at you. And right at the top there, it even gives you a forecast lead time. It says in 42 minutes, the HPI is going to be 104 gigawatts. That means get outside. Um, yeah, and the cool thing is we're discovering different types of aurora all the time, different formations. We've discovered streaks, the subaraural SAR arc. It's a stable aurora red arc that actually can appear due west. So if you're out looking for aurora, look for some of these subaraural arcs too. You may not see the northern lights, but you may see a subauroral phenomenon that's happening in a different part of the sky. The SAR arc, or the stable aurora red arc, appears directly west often. Sometimes it's only visible with the help of a camera. It can be really faint. Steve is the one with the stripes here, Steve and the picket fence. It stands for the strong thermal emission velocity enhancement. And that, for us in Michigan, is typically seen in our either right overhead or in our southwest. And so you guys might be able to see Steve more often than we can, which is really cool. And the thing about all these different types of subauroral arcs is that scientists want to know. So you can go to places to report these and report your findings, and you may even end up published in a scientific paper. One of those places is actually funded by NASA. It's a project called Aurora. So any dinosaur fans in the room, aurorasaurus.org will help you with aurora sightings, has a really great newsletter and news. And it also, you can report your sightings there. And Skywarden, based out of Europe, is another place where you can report them. But report what you're seeing in the time, date, and place with the photo. You can actually help scientists identify some of these things we've never seen before. And part of it is because we have cameras with us all the time. More people know how to catch the northern lights. We're helping each other out. This one is one they called the continuum emission. And and here's that SAR arc we were talking about in a photo by admin Patrick Grupa, who yells, "Get outside now." But they've got a whole field guide to help you identify these, and that's on our website as well. There are so many. It's almost like playing Pokemon Go. Gotta catch them all. So what are the signs? You're looking for G storms. G2 storms are higher, a KP6, KP7, KP8. Keep in mind when you see KP, the P means it's a planetary average of the values they're recording at 13 stations around the globe over the last 3 hours. So when you see that KP, it is an average of the past. K is actually the real value. The ovation model with 90 to 100 gigawatts of hemispheric power or more, or just really great favorable solar wind data. So May 2024 was the strongest geomagnetic storm recorded in 21 years. That's what the ovation model looks like that night. And I was called up by USA Today asking, when's it going to happen again? But you can join us. I don't know if you're coming up from Florida or not, but we've got events all throughout the year and festivals, and we do announce our guided chases online. I also obviously co-founded the Aurora Summit. I think it'll be held up in Michigan this year, and we're still determining the date, but everyone is welcome to come to that too. I think last year we had 18 states represented and 2 or 3 countries. So it really is a national gathering for this kind of thing. And there's a photo. Christina Cantu Sharp took it of me chasing aurora at sea in Norway, just to kind of end up the talk or wind down the talk. And there's how to find me. So thank you so much, you guys. Sorry, that was a bit long.
Perfect. Thank you so much, Melissa. That was really interesting. We got a couple of questions if you're able to stick around.
Yeah, I'm good if you're good.
Cool. So Frank Kane asked a couple, why is the blue glow of nitrogen so rare, given that most of the atmosphere is nitrogen? Is it just really hard to ionize nitrogen?
I think that's probably part of it. I also think it might have a lot to do with what altitude the nitrogen is hanging out at. Um, but yeah, I honestly haven't studied that one in depth. So that's a really good question.
And his follow-up, is it possible to capture real-time video of aurora while still capturing the colors?
It is possible, but it's really, really tough. In fact, I think of real-time aurora video as one of the hardest media to master. But there are some photographers out there doing lessons and offering tips on YouTube, and so you can totally explore that as well.
Nice. Bill Castro asks, are you aware of any studies on sunspot size and shape that would most likely cause flares and CMEs?
So there are a lot of studies on that. I think in general, I mean it really I guess I'm not aware of any specific ones. But in general, really a huge sunspot is going to be more interactive. They, are more dynamic and produce more for us. They also find that when you have several sunspots coming together, sometimes that is generating some of the most potent solar activity.
I had a question of my own actually. Does the latitude that you're viewing at, does that dictate how rare those other colors are? Like would the blues and the pinks, are those
I
more likely
think
the farther north
so.
you are?
Yeah, it's interesting. I've never seen the Southern Lights, so you can also see the Aurora Australis in addition to the Aurora Borealis, which you know. But when I look at photos of the Aurora Australis, they are always much different than what I'm seeing in the Aurora Borealis or the Northern Lights. So I think part of it would be the air composition in that region that you're dealing with, and actually the SAR arc. There's a Aurora chaser who catches lots of aurora on the mountains in the ridges in Virginia, which is so far south, but he's high elevation, which helps too. And he caught the SAR arc in so much brilliant red. Now, the thing about the SAR arc is they actually found out that it emits heat as part of its process. That's part of what's creating that light. And it seemed like the hotter I mean, this is anecdotal, so I haven't seen research on this, but it seemed like the hotter we got that summer, the brighter that red that SAR arc got. Um, but I would say yes, the colors will be different. I think it's largely due to what you're finding in your region in terms of what's in the air. But it also, the closer that you are to the auroral rings, the more color you're going to see. That's almost always true unless that auroral oval is so strong that it's pushing all the way down into the southern US. Um, because it's a lot of times Michigan Aurora Chasers get disappointed because they see these photos and then they go out expecting to see this with their eye.
Yeah.
And we really are in it for the art and we're in it for catching whatever we can. I mean, think about the photos of a nebula you see,
Mhm.
right? Or the Milky Way. It
Yeah.
doesn't always look like orange and purple in the beautiful photographs. We draw that out because we know that's there. It's the color is really there. Our eyes just can't always see it. So, um, but in Michigan, it tends to be more pastel to the eye. And when I go up into Canada, though, not the same. Like it's neon. So I think the closer you get to it, the brighter often.
Nice.
But it depends on the aurora too.
It was also interesting when you pointed out the people see it differently. I can
Yeah.
attest to that. I am red-green colorblind, and when I was in Sweden, my wife could see it. No problem. There it is. I couldn't. I could not tell that with certainty, like, oh, there it is.
Yeah.
It looked the same as like a cloud distantly over a small town or something like that. So,
Yeah, for sure. It makes a big difference. I mean, we have had people for years I was watching this conversation in the groups and it's interesting because people will get like if you want to see one of the most controversial debates in the Aurora community, talk about color. because you will see people get so like riled up about it. And I thought, why is everyone having such a different experience? And myself and Vincent Lavina, who's a really great person to follow, and some other Aurora chasers have really looked into it and talked with a lot of people and asked around and had them compare in real time what they're seeing. And it's just different. So it depends, yeah, it depends on your eye health, depends on your eye history, it depends on the show, depends on your location. I mean, we've had be like I saw a really amazing aurora in my backyard. I recently moved to dark skies, and the people I know living closer to the city saw no color. So
Mhm.
that, that
Yep.
happens too.
Nice. All right. Uh, well, I don't see any other questions, so thank you so much for your presentation. That was really cool.
Awesome. Thank you so much,
You
Jim.
are welcome to stick around for the rest of the meeting, but thank you so much.
Yeah, thank you. Thank you, everyone. I'll be hanging out off and on. My
So,
dog's antsy.
sounds good. Let's get this going again. We go. All right. On to club news. Let's see here. Will it work? There we go. All right. This weekend, currently, we have our Geneva Dark Sky Night scheduled for January 16th and 17th. And with the cold snap that's coming, it's looking promising that the weather will hold. So keep an eye out on groups.io to see if that announcement is made that that is a go. So fingers crossed, guys. Our remote Sea Star out in Texas is still going strong, and it's got a lot of availability. And with it being so cloudy here for the last like couple weeks, try it out. It's really cool. We've got some good examples later of images that were taken from there. Those dark skies in Texas are something else. Let me tell you, it makes a difference. Um, We've got another thing on the horizon, the sponsorship committee. If you have any interest in helping the club grow, seek donations, sponsorships, contact John Frank. He's our one of our BMALs on the board, bmal1 at cfas.org. Give him a shot if you're interested in helping out. Um, this is to all members, new and existing. Are you on groups.io? Make sure that you join. That's where we make a lot of announcements. There's where our calendar is. If you don't know when a meeting is or don't know when a Geneva Dark Sky night is, it is on our calendar on groups.io. So be sure to join that so that you can see everything. It also has people from everybody in the club, the community of the club is there, always willing to help out, ask questions, interact, see who's who and where everybody is in the area. You might even be able to link up and do some astronomy together. So join that if you're not on there. We have some outreach events coming up, as you can see. Our outreach Superman, Doug Woods, is going to be busy this week, the rest of this month. January 20th, we've got the Esplanade Men's Club solar event. So if you're at all interested in helping out with a solar event, if you have a solar filter for your scope, come join in on that one. And then that same night, Umatilla Elementary School, a STEM night. Scopes are needed for that. January 23rd, Princeton Elementary School is going to have a moon party to check out the night sky. And then on January 24th, the Bach Tower Starry Night. That one's a cool event. I actually like to try to check that one out myself. So that one's really cool. I think we have some pictures on groups.io maybe from that one last year. January 28th, Southwestern Middle School Family Fun Fest. January 28th, Lake Nona Middle School, a STEAM night with night spelled like that on purpose. January 29th, Telescope Thursdays at Avalon Park. I did that one last year, and I think there were probably 20 to 25 of us or so, if I remember. It's a big open park area, hundreds of people, maybe even thousands of people coming through looking at through the telescopes. That one was fun. I enjoyed that one. I'm going to try to make it to that one this month too. And then finally, January 31st is the Suds and Scopes, Deviant Wolf. So I must say, if anyone is interested in participating in outreach, it is very rewarding when you set up a telescope and have a 6-year-old, 60-year-old, 40-year-old, who doesn't matter who, when they look through the scope and see Saturn or Jupiter for the first time, or even just the moon, and you get that wow. It's very rewarding. I highly recommend it if you haven't participated in an outreach event. give it a try. The club and the community could really use the help. If you are interested in joining in on outreach events, join our groups.io group, the subgroup, the outreach. There's the link to it. Give it a click, join in, and see what events you might be able to attend. Uh, if you are a new member, be sure to check your Welcome to Central Florida Astronomical Society letter. That gives you the details on how to join the community on groups.io. It explains your member benefits as being part of the club. And if you have any questions, this goes for anyone, new members and old, feel free to contact our board members at large, John Frank and Denise Woody, BMAL1 and BMAL2 at cfas.org, or me, president at cfas.org. All right, the board needs you. We're always looking to get more volunteers to help out with the club, do more for the club as well as for the community. Specifically, the outreach community could use a hand. Doug, again, our outreach Superman, he does a lot of events, and he could use a hand getting more scopes out at more of these events. So if again, if you are at all interested in that, join our groups.io subgroup for that, or reach out to Doug directly at outreach@cfas.org. You can serve on any community. All of our community chairs could use an extra hand. We're always looking for more volunteers. So if you have any interest in helping out with events, programs, outreach, treasurer, loaners, science, website, membership, observing, education, or make your own, come up with your own idea on how to make the club a better place for yourself as well as all of the members, um, please reach out and see what we can do to work together for our club. We're still, of course, in need of mentors. Our mentorship program is still underway. We're still working on that. So if you are interested in being a mentor or a mentee, be sure to contact us about that. If you want to, any other way you want to help with the club, again, please contact John or Denise at the B-mail addresses or myself. And again, as always, the club is a 501c3 organization. Donations made to the club are tax deductible. We're always seeking more sponsorships and corporate donations. So if you happen to know anybody, please let us know. We're also on Cyber Giants, so some major corporations do match donations, like Disney and the other big ones. So check that out if you can. Upcoming astronomical events. Saturn and Neptune are leaving us, but they are still in the early evening sky. Saturn, last time I looked at it, the rings were still pretty edge on. So if you didn't have a chance to see that, now is the time because I think when it comes back around next season, the rings will be back. So it's sort of an interesting view to look at Saturn, and it's just a line through it like that with the rings being edge on. Jupiter is coming up in the late evening. It was at opposition just a few days ago, so it's still one of the best times of the year to check it out. Uranus is going to be near the Pleiades right now. Might make for an interesting astrophotography shot to get in there and check it out. And it'll still just be like a little blue dot in your picture, but you'll be able to say like, hey, there it is. Cold nights are coming this weekend. I don't know if you've checked the forecast, but I think we're in at least parts of our area, where I am at least. We might have some freezing temperatures on Friday and maybe even Monday. So usually that's paired with some clear skies. So keep an eye out on those astro weather apps. January 15th, tomorrow is the new moon as well. So be sure to get out there if you can and check things out because new moon, we can see things. January 30th is the full moon, and that's going to be near Jupiter. Again, might make for a decent little framing shot for both of them. And then later next month, February 18th, the moon is going to be near Mercury. It actually does occult, but I think it does it after it gets down below the horizon. So if you were in another part of the world, you might be able to see that. But still, it's going to be very close, and it might make for a cool image. And then the very next day, Mercury reaches its greatest elongation. So if you have a low horizon or you climb up on something tall, you might be able to see Mercury. So that'd be cool next month. And then finally, we get to our astrophotography showcase. We had a bunch of images come in as we should have with our November and December. It was very nice. So if you are here, feel free to unmute yourself and tell us about your image. So first up, we've got Jeffrey Merrick. I saw him in the list. Jeffrey, you're here
Yeah,
somewhere, yeah?
I'm here.
There you go, sir. Okay,
Here
here we
I
go.
am. Where are you? Oh, yeah, yeah, that was again galaxy interactions on a group of galaxies in the constellation Andromeda. The of this grouping is about 335 million light years, and the magnitudes range from 13 to 14. And this was taken with 72 subs at 2 minutes each. And it's labeled as I don't have it down here. But anyway, it's those two or three galaxies in the upper part of the image. One is a spiral. It's those galaxies that are interacting. And the others are just groupings of galaxies. So,
Awesome.
yeah.
And was this with your, you have a Mac Newt, right?
Yeah,
Something like that?
I have a
Yeah,
Magnum 190,
yeah,
and I find that's a very good instrument for really picking out a lot of these small objects, peculiar
yeah,
galaxies, interacting galaxies, and faint objects, really. So
yeah.
it's a very
Fantastic.
good telescope for that. Uh, Not so much for large nebulae, though, because
Yeah.
sometimes it just goes outside the frame. So,
Still look very cool. Fantastic.
yeah. And of course, this is an upside down penguin, but this is Op 142. It's again part of the Op catalog. It's a pair of interacting galaxies, actually, and it's forming the shape of a penguin. And this has a magnitude of about 13. And again, its distance is about 352 million light years in in the constellation Hydra. Again, this was 98 subs at about 2 minutes. And again, this was with my Magnum 190. Uh, and it works out pretty well. So,
Mm, nice.
mhm,
Very cool. Very
yeah.
cool. Thank you, Jeffrey.
Okay.
John Pinto. I think I saw you in the list there. You there, John?
Yep, I'm still at work, but I've got my phone on so I could respond to you can hear me.
Nice. I can't hear you. Yeah. Tell us about your rosette.
All right, so this looks like my S30 on an equatorial wedge. And I believe, if I remember, this was actually from my driveway. Uh, it says 61 minutes of integrated time, but probably took really about 90 minutes. Dropped frames and internal processing within the S30. But this is one of the reasons I love the S30. It's just you can basically get these huge objects without having to worry about doing mosaics and wasting time. And you can see quite a lot of detail with a little 30 millimeter lens. It just blows me away.
Yeah. I mean, for any scope, that's pretty good for just 1 hour. So
Yeah,
very
yeah.
nice.
And again, this one I believe I was in Geneva. Yeah, I think this was from Geneva, one of our dark sky nights there. Yeah, 82 minutes. And again, with the S30 on a wedge, just let it run. It takes care of itself. I think Wes, you even stopped by that night, and like that's from a 30 millimeter scope. Yeah, yeah.
Nice.
I just love it, and all the background stars just they pop.
Nice. That wedge really makes a difference. That's awesome. Mm,
And of course, we have our favorite, the Horsehead. And this is just the S50. And this one is alt as. Um, and again, just look at that 12 minutes. I just could not believe you could get that amount of detail in just 12 minutes. Normally, with a visual scope, this is like impossible. And you can
Oh
do
yeah.
this in 12 minutes with a 50 millimeter. It just blows my mind. And you
Nice.
also get a little. I think that is a meteor trail. I don't think that's a satellite.
Oh really? Oh,
Yep.
that's cool.
Yeah.
That's
I
very,
forget when
very
this was.
interesting.
This was can you read the date on the bottom of that? The beginning of
Uh,
December.
December 16th, I think is what it says.
Yeah, so that might have been an Ursa. Oh no, sorry, a Gemini. Gemini.
Awesome, awesome. I love the
I,
Horsehead. It's one of those things, for that's one of the images that got me into astronomy actually when I was a teenager, is seeing that one. So,
yeah. It's again anybody who is not into astrophotography and has just any desire to try it. These are inexpensive enough to wet your whistle, get your feet wet, um, and you're not spending thousands of dollars to find out.
certainly. And also to plug again our remote scope out at Starfront. This is the scope here, the C Star S50. This is the kind of scope we have out at our in Texas at Starfront Observatories. We have one of these there. So if he can take this in his backyard or front yard driveway, imagine what you can get at a dark sky. I think it's pretty sure it's a Bortle one. So yeah,
Thanks, Wes.
yeah. Thank you, John. Brian, I saw a Brian in the list. I don't know if it was this Brian Stevenson. You
Yeah,
around?
he was.
All right, cool. There you go.
Right. So this is my rosette over the last, I think so. I started this when it first came up. So I think total data was like 45 hours. But after I called everything out and got rid of all the bad frames, I think its total stacked is 21 hours, which was still pretty nice using the LP filter because you could actually start to see some of the purple show up in the core. Um, I'm going to do another 20 or 30 hours on it and see about getting,
Ooh,
yeah, like if I can just stack that probably at the end of this year and then see what happens. But yeah, this is all just getting collected over at my house in Waterford Lakes and then in Geneva, just going back and forth
awesome.
between the two.
So your goal is like 50 to 60 hours or so in total. That'll be
Yeah,
something. All
yeah,
that outside stuff that's in the area that should come through.
yeah. So that's the thing too, is this scope is super wide and I was having some issues with calibration frames. So I had to crop it in and kind of lost a lot of the nebulosity there. But you can, before I started getting rid of bad frames and you could really see the cloud on the outside, it's crazy how much extra gas is up there that I didn't even know about.
Nice, very nice. I'll be excited when you send that to me sometime this year. Thank you,
Yeah,
Brian.
so
Frank, I know you're here. I saw your question.
Yes, I am. Can you hear me?
There he is. How you doing, Frank?
Cool. Doing good. Yeah. Welcome from the LA branch office here, I guess. So,
Exactly.
um, yeah,
So
this is
here you
stuff from
go.
our telescope rig that's hosted out in Starfront, neighbors with the Club Sea Star, and those dark skies come in handy. This is the Flame Nebula, and no narrowband tricks here. This is just straight up wideband RGB data over 10, 15 hours, something like that. But yeah, just those dark skies just really pull that detail out and all that dust around it. So pretty happy with how that came out. This is from a Astrophysics GTX 130 scope on a Paramount 90 mount and a Player One Zeus full frame camera. And I have caved in and started guiding again because those full frame images get really big really fast. So you want to have not a lot of small exposures, but a few large ones are a lot easier to manage. And for that, you need guiding.
Nice. And this was LRGB, right? Because I compared it to mine that's narrowband, and there's some of that reflection nebula there stuff that you definitely picked up here that it's not in mine. That's a cool comparison.
Yeah, that's the cool thing about this object. A lot of people just hit it with narrowband, and there are definitely reflection structures in it that you don't see at all in narrowband. So I actually threw a bunch of SHO data at this as well, and you're right, it's just a completely different character. But
Yeah,
yeah, two different
cool.
takes on the same object.
Here we go.
The tadpoles. So speaking of narrowband, this is straight up narrowband. So even though we have dark skies in Texas, the moon is still a thing there. So you need to have a backup plan for when the moon is up. So it's always good to have some narrowband emission targets like this one. So this is the Tadpole Nebula for obvious reasons. Two little tadpole-y things there, kind of like screaming up from the bottom there. But yeah, this is all narrowband SHO Hubble palette data. I forget the exposure time, but I think it's about 15 hours total.
Not bad at all. I love the detail on the tail part. Those usually get lost in the weeds when from other places. The dark skies really help bring out that stuff out. Very cool.
Yeah, and the oxygen really makes a difference out there too. So, those dark skies make the oxygen, that blue stuff, really pop. And here's the Witch Head Nebula, kind of a different take on this as well. So I'm kind of limited by my narrow field of view here. The star Rigel is off to the right there, and in wider frames, you can actually see the witch kind of staring at Rigel, which is kind of a cool thing. Wes, I know your image had that, which is really awesome. But that means you also have to tame the brightness of Rigel itself in the image, which is another challenge. But the cool thing here is that I actually integrated some hydrogen alpha into this image as well. So it's not just the reflection LRGB data, but there's also some hydrogen that I took some time on as well. And there actually is a lot of hydrogen in this area. It's in Orion, so Orion's just full of hydrogen, right? And you can actually pull that out, and there's kind of this ionized hydrogen kind of like glowing behind it that a lot of people miss. So I think that's kind of a cool take on it.
That is a cool take. I like it. Very nice. And the detail on the little spirals up in the top there, very nice.
Yeah, actually, that was kind of tricky to process because they kind of want to blow out when you stretch the image, so a
Yeah,
little bit of
that's
care on
for
that.
dim reflections like this. Yeah.
Right. The Pleiades M45. So this is me playing with that new Verilux thing. If you've been following all the recent innovations in stretching in PixInsight, Verilux kind of like led the way in having these sort of new ways of stretching images that preserve their colors. And by using that, we got kind of this more rich blue flavor around the Pleiades here. A lot of people don't realize that there's kind of a blue reflection nebula kind of surrounding that whole part of the sky there. You look at it, it's just kind of like,
Yeah.
the Subaru logo, but in reality, it's a really fascinating part of the sky with a lot of dust around it as well. And I've also been playing with that new, what was it, multi-scale adaptive stretch thing in PixInsight. I think that one's better, actually. So maybe next month I'll show you that one. And also the
Awesome.
statistical stretch script that a lot of people use got an update recently as well to better preserve colors. So you should be seeing a lot more colorful images soon, I think, as a result of all those innovations.
That's awesome. Yeah, competition is what we need, right? When you have one thing, it gets glazy, but then when you have three, then they makes everything better for everyone. So, and I also like
I
that
know. Yeah,
you have this upside down compared to how we almost always see it. So, cool.
yep. It's all about what looks pretty to me. Thanks.
Exactly. All right. Thank you, Frank. Much appreciated. All right. Pete, there you are. Yeah.
Yep, here. Yeah, so Wes, this, unlike John's earlier image with the S30, this is, to get this amount was, had to be a mosaic with the C Star S50, and this is taken with the S50 we have out at Starfront. So it was early December. There was a moon, so I just kind of timed this to when I could get some shots, and I just did it over multiple nights. And speaking of your plug for Groups.io, Quinton, seems to be very expert at PixInsight, at a very in-depth posting about improving your images through subframe selector. So I studied that thing pretty deeply, and I had thousands of subframes for this mosaic because you got to have a lot of extra subframes in order to get the same detail in your image. And because of dealing with the moon and some clouds, I followed his advice in that article and figured out how to make those work, and it really helped enhance this image. But yeah, early December is about after the subframe selector ended up with about 8.5 hours in this image. And I did end up, I used GHS and PixInsight as well as that MAS, that new stretch. And I ended up, just for this, I mean, that MAS, just ended up with a little bit more color, which I thought would be better for this. But I really tried to focus on, since this object sits in a sea of, I don't know, clouds, cosmic dust and gas, I tried to at least impart that in the way I process this image. But again, dark skies, even with the moon, you can work around the moon. So
Certainly. Yeah.
try the remote scope.
Yep. That is a solid M42 and M43. That's really cool. Again, plug If you are not already on there, check out scheduling some time on our remote sea star out there. It's very cool. Thank you, Pete. Oh yeah, and the other one, yeah, you got another
Yeah.
one from there.
Yeah, and this one was another mosaic, it was or kind of around the second week of December. And someone on Astrobin had done this, I think a 15-hour total exposure with, a pretty sophisticated telescope. So I just thought I'd try to reproduce it with the S50, and I wanted to image that silver sliver, I guess NGC 891. That's the um, object up there in the upper left. And I think I ended up, this one was a bit more challenging, and that's where the subframe selector came in handy because that Quentin spoke in his article about, the eccentricity of the stars.
Mhm.
And so, mostly this was stars. I ended up, probably only getting half of the subframes after going through, but I did comparisons between, you know, just using the fast batch pre-processing alone and then using it in combination with some of the techniques that Quentin had outlined, and night and day difference, especially at these star fields. But you zoom in this photo far enough towards the center. I mean, there's just galaxy after galaxy popped up in this thing, even with the $500 telescope. So
That's so cool.
dark
That's
sky.
when you get lost in the weeds looking for like, which one is the farthest away, and you start looking in your astronomy app, like trying to find the really distant ones.
Yeah, when you
So
do the astrometry, or whatever on Astrobin, and it just pops all of the galaxies that are in that one little.
yeah,
It's pretty amazing.
that's super cool. From an S50, from a $500, now $550 scope.
Yeah.
Super cool. That's amazing.
Use groups.io because you really find some interesting tidbits, and some super knowledgeable people are posting some helpful things like using subframe selector.
That's right.
You want to get much better results.
Yeah. More
Start.
with less, right? Yeah. Thanks, Pete. Very, very cool. Zach, I didn't see you in the list, but did you join? Nope. Okay. Zach sent in, he's one of our newer members. He was at Geneva last year. Um, he sent a couple of photos. I think a couple of them are probably phone smashes, but I think the one on the left might have been with a DSLR, but those are some solid little shots of the moon. It's pretty good detail on some of the mountain ranges and craters there. So very nice, Zach. Cool, good job. Um, I really like the one on the right where the detail in those mountain ranges is very nice, and that might be a phone smash shot too. So very cool, good job. And here's a couple others that Zach sent in. These are obviously M42, but as someone that started off in astrophotography, I feel like you have to start with a shot of M42 like this to sort of cut your teeth on things. Like we all have this, and we take this picture and we see M42 for the first time, the Orion Nebula, and it looks like this, and it's just so cool. Like I took that. That's so cool to get the nebulosity and the glow. It's really, really satisfying. So. Good job, Zach. Greg, Greg Root, are you around? I don't think I saw you on the list, so you might not be. Yep. Okay. Greg sent in a couple of nice Milky Way shots here. If I remember the story right, this one was taken somewhere in Florida, somewhere near Kissimmee, some ranch down there, and he wanted to illustrate how this image being more near light pollution, how it compares to the image on the next frame. So you have this nice image from Florida in the Kissimmee area, I believe, compared to one from Yellowstone, the darker, much, much darker skies of Yellowstone. So you can see the difference in like the sky glow on this one versus that one. So again, back to what Melissa was talking about with dark skies make a difference. They really do. So if you can get out to a dark site and try it sometime with any kind of imaging, it's impressive. I threw a couple of mine in there, just President's prerogative. So here is my image of the Embryo Nebula, NGC 1333. I really like this object. I think I did a pretty good job with this image, but it's a very dynamic image. There's a lot of things going on here. You have the reflection nebula, the protostars in there, these Herbig-Haro objects going on in there. There's this whole, it's a different looking object than a lot of things you see. Um, I took this one with my Edge HD 8 at Astrofest up in Chiefland back in October. And then this one I also did at Chiefland back in October with my little red cat and the Player One Zeus. This is the rotten fish and dark shark in the Cepheus area. So that area has a lot of dusty, dirty crud just floating all around. And if you're in a nice dark sky, you can pick this up in not too much time. I think this image was only about 10 or 12 hours. So it's very doable when you're in a dark sky. So it's worth it to get out there sometime if you can. Not always, but if you can, give it a shot. Sam, I see you right there.
I am here.
All righty.
So this one, I was really impressed when I saw JP's picture. It looks almost identical, which is
Yeah.
great. But for those who know me or have met me, you probably know I suffer from aperture fever, and it's tough to haul the big telescopes and all the camera equipment around for them. So I decided to pick up a dwarf, and I've been playing with it. I've only had it about a month. This is over the course of 3 nights. I was able to capture about 3.5 hours. And this is straight out of the dwarf without any post-processing, just stacked 3 days worth of data. It came out really nice. I'm very impressed. Started with the rosette because of how big it really is, to try to capture it. Considering, the rosette's like 7 full moons wide. So
It's pretty big.
very cool. I was very impressed with what this little tiny digital telescope can do.
Super cool. That Sea Star has some competition, huh?
Yeah, they're very, very similar. I think the D3 is 55 millimeter and the Sea Star is 50. So they're very, very close.
Super cool. Very nice. Was this taken at your house, or was this Geneva?
Now, this was a combination of Geneva, the past, Friday until the fog rolled in. I got probably almost 2 hours. And then the weekend before, about an hour, also at Geneva. And the rest was from my wonderful Bortle 9 backyard in Orlando.
I hear you. Well, still, that's awesome. Good job with this one. And yeah, I think, Sam, that was the last one. So let's see here. Yeah, I think that's pretty much it for tonight, folks. Thank you so much for sticking around. Let's see. Are there any questions popping in here? Yeah. Cool. Well, thank you everyone for sticking around and checking out the astrophotography showcase. A special thanks again to Melissa for her presentation. That was awesome. Again, if you're at all interested in the outreach events later this month, please check out groups.io and check that out. Contact Doug if you are able to hop in on any of those. They're very fun. I enjoy the outreach events. Get in there if you can. So thank you, everyone. That brings the meeting to an end, and I will see you all next month.
Thank
Take care.
you so much. Take care, guys.